Number 1, rewrite each of the following exponential expressions involving rational exponents as radical expressions. Evaluate the expression without a calculator. So in this lesson, we decided what it means to have something to a fractional exponent. What does it mean to have x to the m over n? It doesn't mean I have some fraction of x being multiplied. It doesn't make sense to use that intuitive definition of exponents. So we said if I have something to a fractional exponent, that denominator is the type of root. It's a radical. It's the nth root of x to the m. It's the nth root of x to the m. Or you could take the root of it first and then raise it to the nth power. But it's power over root is our mantra for when we deal with fractional exponents or rational exponents. So if I have 64 to the 2/3, I have a 2/3 power, which means that it's a third. So I'm taking a cube root of 64. I'm going to square it. Well, normally when we deal with numbers, we want to make them smaller first before I make them bigger. So the cube root of 64, what times itself 3 times gives me 64? Well, that's 4 squared, which is 16. 125 to the 2/3. Well, I have a 2/3 power again. That's power over root. So I'm going to take the cube root of 125, and then I'm going to square it. Power over root, squared over the third root. So the cube root of 125 is 5. 5 squared is 25. 16 to the negative 3/4. So I have power over root. I'm going to take the fourth root of 16, raise it to the third power, but that negative is going to throw me in the denominator. That negative is going to take the reciprocal. The fourth root of 16, what times itself 4 times gives me 16? Well, 2 times 2 times 2 times 2. So it's 2 cubed. 2 cubed is 1/8. So power over root is our mantra when we deal with these fractional exponents. Explain why we define 5 to the 1/3 as the cube root. So we know that 5 to the 1/3 cubed must equal 5 because of our power to a power property. We multiply them, a third times 3 gives me 1. So 5 to the 1/3 cubed, if I have that power to a power there, 1/3 times 3 should give me 1, so I should get 5. So I want to know what that is. What cubed gives me 5? What number cubed gives me 5? Well, the cube root of 5 cubed gives me 5. So that 5 to the 1/3 has to be the cube root. That denominator there in your exponent is the type of root that you're going to be taking. The expression w to the negative 5 over w to the negative 9 to the 1/2 is equivalent to w to the a. Determine the value of a. So let's deal with this expression inside here. Maybe you use the subtraction rule, negative 5 minus negative 9, or you can say, wait a minute, negative means take the reciprocal of it. So that w to the 5th is going to move to the bottom. That w to the 9th is going to move up top because they have that negative exponent. I have w to the 4th. When I subtract, 9 minus 5 is 4, which is exactly what you got if you didn't do that move first. To the 1/2. Now I have two options here. I can use power to a power, 4 times a half is 2, or I can say I have the square root of w to the 4th, which is w squared. So what's the value of a? A equals 2. A equals 2. Let x be a positive number. Maria claims that 4x to the 1/2 equals 2 square roots of x. Explain Maria's mistake and correct it. So Maria found this. Maria found that the 4 is not being raised to the 1/2 power. Only x is. X to the 1/2, a 1/2 exponent means take the square root. So it should really be 4 square roots of x is our answer. Rewrite the following expressions in exponential form. So I'm giving you the radical form. I want to know what's the exponential form. So I have the square root of 5. So there's really an index of 2 there. So that's really square roots. We need to know our 1/2 powers. I've got a cube root, so I have a third power, but it's squared, so 5 to the 2/3. I've got a square root. Square roots are halves. So 1/2 power, 3/2, power over root, power over root. And finally, I've got a cube root. So I've got 5 to the 1/3, but it's squared, so to the 2/3. Which two are equivalent? I can either take the cube root of a square, or I could square the cube root. Both of these expressions here are equivalent. They look different, but they have the same value. Is it true that 4 to the 1/2 cubed equals 4 cubed to the 1/2? Explain how you know. Yes, it is. Power to a power tells us to multiply. Power to a power says I have 4 to the 3/2 and 4 to the 3/2. So they are equivalent. What this tells me is the square root of 4 cubed is the same thing as the square root of 4 cubed. The square root of 4 cubed. I can square root first, or I could cube first. It doesn't matter the order, because I have that property of exponents. I have that property of exponents there saving me.